I welcome you for this presentation. In this presentation, we are going to discuss about association rule mining. This is the overview of this presentation, that is frequent pattern analysis, then a priori algorithm, then association rules. Then I have I have given one example with respect to the a priori algorithm and how to generate the strong association rules. Then I have given two practice problems, then summary of this presentation. So first is, what is the need for frequent pattern analysis? And this topic is in the third unit. I have left some topics in the second unit. The reason is, if we third unit is a very important unit, so that it will be helpful to do your project. So that I am finishing off third unit, then I am coming to the second unit to cover all the topics. So here the need for frequent pattern analysis. Why we need the frequent pattern analysis? Today in the market, this frequent pattern analysis plays a vital role, because which product the customers are buying, whoever is buying one product, whether they are interested in buying the related product. For that only this frequent pattern analysis is there. So this is another name for this is market basket analysis also. So here we are analyzing the patterns, frequently available patterns we are analyzing. That is called as frequent pattern analysis. That is a pattern. Pattern means some set of items or subsequences or some substructures that occurs frequently in a data set. So in a transaction data set, that is in a market data set or in a sales data set, which are the items are occurring frequently, that we have to analyze, and based on that the shopkeepers or the supermarkets, they used to give some offers, so that they will be getting more sales with respect to that particular product. For that only we are having this frequent pattern analysis. So the main motivation behind this frequent pattern analysis is to find the inherent regularities in the data. That is, what products were often purchased together. One example is beer and diapers. This is a very famous example. Beer and diapers, why it is given means young fathers used to buy the weekend, that is on Fridays. There was more sale of beer as well as diapers. The Walmart analyzed that, and they have given this in the examples of most of the big data mining, frequent pattern analysis books and all. This beer and diapers example is there. So this is a very famous example, because the young fathers used to buy diapers on Friday. They also used to buy beer, so that whoever is buying diapers, they are buying beer. Likewise, some analysis was performed by Walmart, and it is given in very reputed journals and all. Then what are the subsequent purchase after buying a personal computer? So while purchasing a personal computer, most of us used to buy a laptop. What else? For a personal computer, we used to buy printer or antivirus, something like that. Everyone used to buy those things. Suppose we are buying a laptop, sometimes the laptop bag will be given as free. Otherwise, we used to buy a laptop bag. Then some external keyboard we used to buy sometimes. Sometimes we used to buy wireless mouse. These are some of the things we buy while buying another product. So these are the related items. So what are the related items the customers used to buy? For that only the shopkeepers or the supermarkets, they are analyzing that. That is the market, they are analyzing. Whoever is buying these things, most probably they used to buy the related items, bread and butter, likewise many things, bread and jam, likewise many things. For each and every small item to very big item, they used to analyze, and they can give some offers or something like that, so that they can improve the sales. Main thing is, we are having so many data. With the available data, we have to convert the data to some data product. That is, we have to get some interestingness from the data, so that we can improve the business, all those things. Another thing is, what kinds of DNA are sensitive to this new drug. In the drug designs and all, what DNA is sensitive to the particular drug, like that they used to analyze. Another thing is, can we automatically classify the web documents. For that also frequent pattern analysis plays a vital role. Say for example, in the Google search, we used to give a word or some sentence. At that time, the related all those web links are coming in. So these are the related web links. So they are here also we are performing the frequent pattern analysis only. So this frequent pattern analysis are applied in basket data analysis, then cross marketing, then catalog design, then sale combine, then weblog clickstream analysis and DNA sequence analysis. Not this much applications, many more applications are also available. It is used. So this frequent pattern is an intrinsic and important property of the data sets, and it is found in many essential data mining tasks, that is in order to find the association between the two items, or in order to find the correlation, then in order to find the causality relationship, that is one event happens before that particular event. Likewise, some relationship is exists between two events. In such cases also we can use this frequent pattern analysis. Another thing in sequential, structural, that is subgraph patterns and all, also this frequent pattern analysis plays vital role. Then pattern analysis in spatio-temporal, then multimedia, time series and stream data, and mainly in classification, because using this frequent pattern analysis we can generate some rules, and those rules can be used to classify the data. In such cases also this frequent pattern analysis plays a vital role. Then in cluster analysis, that is frequent pattern based clustering is there. Then in data warehousing, that is in iceberg cube and cube gradient, there also we are analyzing the frequent patterns. Then even in semantic data compression, that is in fascicles also we are using this frequent pattern analysis. Not the list is not this much, it is used in many broad applications, that is our many more applications are there. There are in all the places, most of the places, this frequent pattern analysis is used. So here we are going to discuss about the basic concepts behind these frequent patterns. That is, what is the item set, what is K item set. Here are two important terms are there, that is support as well as confidence. Based on the support and confidence only, we are extracting something from this association. We are extracting the association rules. So here the basic concepts involved in frequent patterns include item set. Item set means it is a set of one or more items. Then K item set means X contains K items, that is X1 up to Xk. Then absolute support or support count of X, that is frequency or occurrence of an item set X. The support count is very, very important, because in the algorithm to find the frequent patterns we use the support count, that is absolute support count. That is next is relative support, that is S is the fraction of transaction that contains X, that is the probability that a transaction contains X, that is the relative support. Then an item X is frequent if X support is no less than a minimum support threshold. So always here we are fixing a threshold, and based on the threshold only we are selecting or extracting the rules from that. So this is one simple example given, that is a transaction ID. There are 5 transactions IDs given, and for the first transaction the items bought are beer, nuts and diaper. Second transaction beer, coffee and diaper. Likewise 5 transactions are there. So the customer who buys beer we are representing as yellow, and customer who buys diaper, that is we are representing as blue. Then we are finding out whoever is finding both the beer as well as the diaper. So we are finding like this. So this way we can analyze not only with respect to beer and diaper, we can draw the relationship between eggs and milk. Many things, coffee and milk, many things we can use to analyze, and we can find out the patterns. This is one simple example for frequent patterns. Next is basic concepts behind the association rules. Here association rules means we have to find out the rules. Based on the rules, these rules can be used for some classification for purpose. So we are extracting some rules from the given data. So we are finding a rule X to Y. That is, we are finding X. If X is happening, then what is the consequence? This is the condition, and what is the consequence for that, with minimum support and confidence. So support is, that is probability that a transaction contains X union Y, And confidence C, that is the conditional probability that a transaction having X also contains Y. So the difference between the support as well as confidence you must be aware of. That is, support means probability that a transaction contains X and Y. So both combined together, if you are having, then we are calling it as support. Confidence means it is a conditional probability, that is B given A. Probability of B given A is the confidentiality, and support means probability of A union B, that is about the support. See here the formula for the support as well as confidence, support and confidence. So support equal to A implies B equal to probability of A union B, that is probability that a transaction contains both A and B. Confidence means A implies B equal to probability, conditional probability, that is B given A. So conditional probability that a transaction having X also contains Y. So support, the definition for support is an indication of how frequently the items appear in the data, and confidence indicates the number of times the if-then statements are found true. So this support and confidence plays a vital role in this association rule mining. Say in this example, you see the minimum support is 50% and minimum confidence is 50%. If you are taking the minimum support and minimum confidence is 50%, then we are finding out the frequent patterns. How many times beer appears, how many times nuts appear, diaper, eggs and all. Then two candidates we have to choose, that is beer and diaper, likewise beer and coffee, likewise for all things we have to check, and we are finding out the support and confidence. So 50% means how we are finding here, a maximum 3 divided by 5 means what is the percentage you have to check, then 2 divided by 5, likewise you have to check how many percentage you are getting, and if you are getting this 50% means that is 2 divided by 5, we are not getting 50%, 3 divided by only. So always we have to choose the less than or not less than, greater than or equal to this minimum support and minimum confidence. So we have to find out the value like this, that is how many values, that is what are the counts, support count we are taking divided by the number of transactions, what percentage we are getting here, that we have to check. That is for the minimum support. So if it is satisfying that percentage, then you have to find out this is the count. So here 3 is the minimum support equal to 50%, means at least we must have a 3. And then only we are getting, because 2.5 equal to 50%. So beyond that we have to get. So 3 means it is 60%, I think so. So we have to find out 3 minimum support count as fixed, minimum support count as 3. So from this data we are getting beer comma diaper 3 times occurring, other things are coming less. So we are analyzing from this data, and we are generating a data that is beer and diaper is only satisfying the minimum support count. Then based on this we can generate some rules also using the confidence. We have to compute the confidence and we have to generate some association rules. Later on we will see how to generate the association rules. So a very important and famous algorithm for this association rule mining, that is to find out the frequent items, we are having one famous algorithm called Apriori algorithm, that is it is a candidate generation and test approach. So the methodology is very simple. Here initially we have to scan the database once to get a frequent one item set. Always we have to first scan the database and we have to generate a one item data set. Then we have to generate the length k plus 1 candidate item sets from the length k frequent item sets. So next we have to join this one item data set and we have to generate two item data set, then 3 item data set. Likewise it goes on. Based on the minimum support count, we have to stop the condition. That is, test the candidates against the database. Then we have to terminate when no frequent or candidate set can be generated. So this is the algorithm for the a priori, that is frequent items generation algorithm. So here another thing is, after creating the frequent item set, we have to prune it. That is, not all the items in the candidate set are not satisfying the minimum support count. So what we have to do is, whatever the data is not satisfying the minimum support count, we have to prune those things. That is, if there is any item set which is infrequent, its superset should not be generated or tested, so that it is eliminated, and in the further process that particular item is not included. That is about pruning. So here we have to generate a candidate, then we have to check whether it is satisfying the minimum support, that is support count. If it is satisfying, you have to keep it. If it is not satisfying, you have to prune it. That is, remove it from the candidate list. While seeing the example, it will be clear for you. Let us see an example for this Apriori algorithm. Here, this is the transaction database given. So database TDB, transaction database given, and this transaction database consists of 4 items, 10, 20, 30, 44 transaction IDs are here, and it consists of these number of items. So, and also this minimum support count is also given. So support count, minimum support count equal to 2, it is mentioned. Suppose if it is mentioned as some percentage, what you have to do is we have to calculate it. Say for example, suppose you need 2, so 2 divided by 4, what is that? 2 divided by 4 is 0.5. So here the minimum support count is 50%. Suppose if it is given as 50%, you have to find out the value. What is the minimum support count? Here support count is given as 2, so no need to worry. The percentage we can easily compute. 2 divided by, that's support count divided by the number of transaction. Suppose it is given as 50%, you have to compute the value. 60% means also you have to compute. Whatever percentage given, you have to compute the minimum support count. After computing the minimum support count, you have to find out the first candidate, one item candidate, C1. First you have to scan the database and you are generating the candidate data. That is, for each and every single item, that is, here we are having totally 5 items, A, B, C, D and E. So for all the items, you have to find out the count, the support count. So here you have to check for A, how many times it is occurring in the database. That is A here and here. So 2 times. B, C, 1, 2, 3. So B 3 times. Likewise, for all the data, you have to find out the item as well as the support count. Then what you have to do is, we have to prune it. Why we are pruning? Because some of the items are not satisfying the minimum support count. So we have to prune those items. So here D is at having only one support count. So this can't be coming in the frequent items set. So we have to remove it and we are getting the L1. Final list we are getting L1. Okay, so A, B, C, E. So this support count. Just we are removing it and we are getting the final list, that is L1. Then you have to perform, then you have to find out C2. C2 means, how we are finding C2 means join operation we have to perform, that is L1 join operation L1. That is L1 join L1 you have to find out, so that with this only you have to perform, find out the C2 item set. So A to B, A to C, A to E, then B to C, B to E. Then C to E. Likewise, we are generating the items set. Candidates we have generated, that is C2. C2 equal to L1 join L1. So we are getting these things. Then we have to find out the support for these items set. C2 item set. 2 item candidates, we have to find out the support count. So A to B, how many times it is occurring? A, B, 1 time. AC is in the first transaction as well as in the third transaction we are having AC, so 2. Likewise, we have to find out the support count for all the items in the C2 candidate list. Then we have to check whether all the items are satisfying the minimum support count. So whoever is supporting this minimum support count, we have to keep it. Others, whichever is having less than the minimum support count, you have to prune it. That is, we have to remove it. So after removing, we are getting this L2. Okay, here the items with 2 items with the satisfying minimum support count item sets are there. Then we are generating C3. So C3, how we are generating? C3 equal to L2 join L2. So we are getting 3 combinations. So A, B, C combination we will be getting. Then many combination we will be getting, but we have to check that whether it is satisfying. But here three combinations. What are the three combinations available? BCE is there, BCE is there. So BCE is there. ACD, whether ACD will be coming here? Here it is not coming because D is already pruned. So ACD combination is not coming here. Only we are having the combination BCE. Then we are finding how many items are there for this. So 2. So we are just writing it as 2. Support count 2. Here there is no pruning process happen because only one item is there in the item set, and it is also having the support count also 2. So no need to perform the pruning process. So now we are having the frequent item set. That is, frequent item set is BCE with the support count 2. This is the frequent item set. So in this a priori algorithm, the output of the a priori algorithm is it just outputs the frequent item set. So with this frequent item set, after that we have to perform association rule mining. So a priori algorithm just gives the output as frequent item set with the support count. I think now it's clear. I think so. The algorithm. Let us see the algorithm representation. So here we are having CK, that is the candidate item set of size K. LK is the frequent item set. So in the example we have generated C1, C2, C3, then L1, L2, L3. So candidate item set and frequent item sets. So L1 equal to frequent item sets for K equal to 1, LK not equal to pi, K plus plus. We are generating the next count, that is CK, the C1, C2, C3, likewise it goes on. So CK plus 1 is generated from LK, candidates generated from LK. For each transaction T in database, to increment the count of all candidates in CK plus 1 that are contained in T. So in the previous example, D was not included because it is already pruned in the first step itself. So in the coming transaction, that is not included. In the pruning condition we have seen, right? So subset is not satisfying means the superset is also not satisfying. So we have to remove that. That is the pruning condition. Then we are generating the LK, frequent item sets LK plus 1 equal to candidates in CK plus 1 with minimum support count. So finally we are getting the frequent item set, that is LK, final LK we are getting as output of this a priori algorithm. So how to implement this a priori algorithm means we are generating the candidates, that is self-joining LK. How we are generating LK, you know how we are generating LK, then we are performing pruning operation. So self-joining process, then pruning process. Say for example, here we are having L3 as this is another one example, ABC, ABD, ACD, ACE and BCD. Here how we are performing self-joining process, ABCD from ABC and ABD, then ACDE from ACD and ACE. So in the pruning process, ACDE is removed because ADE is not in L3. In the previous step, ADE is not there, so we are pruning that. And finally, we are getting the candidate set as A, B, C, D. This is one simple example for this a priori algorithm, how we are implementing that. Next is generating association rules. This is very, very important because from the a priori algorithm, we have find out the frequent item sets. So with that frequent item set, what we are going to extract, that is we are extracting or generating some association rules from the frequent item set. So how we are extracting the rule, that only we are going to discuss now. So once the frequent items sets from the transactions in a database D have been found, it is straightforward to generate strong association rules from them. When we are calling it as strong association rules means if a rule satisfy both minimum support and minimum confidence, then only we are calling that rule as a strong association rule. So here this formula you already know that confidence A to B equal to conditional probability P of B given A. This already you know. So here how we are computing support of A union B divided by support of A. That means support count of A union B, all. How we are finding the confidence means support count of all, whatever is involved in this confidence, for all we are finding the support count divided by the left hand side A support count we are finding. So this way only we are computing the confidence of any association rule. So association rules can be generated as follows. For each frequent item set L, generate all non-empty subsets of L. Then first we have to generate, in the last example we have a 3 item set with the support count 2. So for that 3 item set you have to generate all non-empty subsets of L. So this non-empty subset must consist of one item as well as two items, because maximum we are having 3. So in the subset we are having one item as well as two items. So we are generating all non-empty subsets of L. Then for every non-empty subset S of L, we have to output the rule minimum confidence, that is S implies L to S if support count of L divided by support count of X greater than or equal to minimum confidence. So we have to compute the confidence and it has to satisfy the condition greater than or equal to, always greater than or equal to. Always you have to keep it in mind, where minimum confidence is the minimum confidence threshold. The threshold is also given like 50% or 70%, 80%, likewise it is given. Based on that we have to find out. So because the rules are generated from the frequent item sets, each one automatically satisfies the minimum support count. Suppose it is given in the question, it is given that find out the minimum support, find out the support and confidence of the rule. It is given means you have to just find out this confidence, that is enough. But support is already, it is satisfying, because in the beginning itself support is given. So support, it is already satisfying. Now we have to, in the association rule mining, we have to check only the confidence, that is enough. But we can easily compute the support percentage also. But already whatever the frequent item sets available, it is satisfying the minimum support count, because based on the minimum support count only we have generated the frequent item set. So it is already satisfying. So let us see an example how to generate association rules. See here, this is the frequent item set we obtained using the while applying a priori algorithm. So here we are having B, C and E, the items, then with the support count 2. And here for this example it is given that the minimum threshold is 70%. So the whatever the rules we are generating must satisfy the minimum threshold of 70%. Okay. So first, what is the first step in order to generate the association rules? First we have to create non-empty subsets. So here we are having 3 items. So we are generating the non-empty subsets like this: BC, BC, then BE, then CE, then each and every item, that is BC, BE, CE, then BCE separately. Then we have to find out the association rules with confidence. So first we have to generate the rule. So for this BC, B comma C implies C. Whatever is not available, that we have to write it in the right hand side. B comma C implies C. Then for BE, B comma E implies C. Then for CE, C comma E implies B. If it is a single, then you have to write the remaining. That is B implies C comma E, C implies B comma E, and E implies B comma C. These are the 6 association rules generated for this item set, frequent item set. But these 6 association rules are not strong association rules. When we are telling it as a strong association rule means, if the association rule is satisfying both the minimum support and minimum confidence, then only we are calling it as a strong association rule. So here minimum threshold, that is minimum confidence threshold, this is confidence threshold, is 70%. Already the support we have calculated. This item set is providing the minimum support only, because it is providing minimum support, though, so only it is given as a frequent item set. So while generating the association rule, no need to bother about the minimum support, because already the frequent items are satisfying the minimum support. Minimum confidence alone we have to compute, that is the minimum confidence threshold given as 70%. So here what we are doing is, we are just keeping finding out the minimum confidence, that is confidence equal to support count of whatever all the items, we have already seen that formula, all the items involved in the association rule, that is BCE divided by support count of the left hand side B comma C. So here support count of BCE, you see BCE, the support count is 2 already we know. The support count of BC in this table, if you see BC, it is 2. From the Apriori table only I have taken this, so it is 2. So 2 divided by 2 equal to 100%. Next is B comma E implies C. So we have to find out the support count of all, that is 2. Then we have to find out for the left hand side B comma E. B comma E, it is 3. So 2 divided by 3, it is 66.67%. Likewise, for all the rules, we have to compute the confidence. After computing the confidence, we have to check what is the confidence threshold given. Based on that, we have to find out the strong association rules. So here only this one and this one is satisfying the minimum threshold, that is always it is greater than or equal to the minimum threshold. So here we are getting only two rules only, we are getting greater than minimum threshold value. So we are writing these two rules as the strong association rules. B comma C implies C and C comma E implies B. So what it means, if anyone is buying B and C items, there is a possibility of buying E item. That is the meaning. So this is about strong association rules generation process. So using the a priori algorithm, we can find out the frequent item sets. From the frequent item sets, we have to extract based on the minimum confidence threshold, we have to extract the strong association rules. So here I have given two problems to practice. Whatever we have discussed, the same procedure only, you have to work out these two problems. But here it is not given. The minimum support is 60% given. So you have to find out the minimum support count. So how to find out the minimum support count? First you have to check how many numbers, how many transactions are there. Here 5 is there. So you check that 2 divided by 5, what is the value you are getting? 3 divided by 5, 3 divided by 5, you are getting 60%. So the minimum support count is 3. Likewise, you have to keep. Then for this data set, we are having 9 transactions. So the minimum support given is 20%. Here also you have to find out what is the minimum support count. 2 divided by 9 means whether we are getting 20% or not. Or 3 divided by 9 means you are getting above the 20%. Always it is greater than or equal to. You have to always keep it in mind. And while extracting the association, strong association rules, you have to consider this minimum confidence. You practice these two problems, then you will be understanding better about this a priori algorithm. So in this presentation, we have discussed about the need for frequent pattern analysis. Then we have discussed one candidate generation algorithm, that is a priori algorithm. Then how to generate the association rules from the frequent item sets. Then we have discussed one example with respect to the a priori algorithm for finding out the frequent item sets, as well as how to extract the strong association rules. Then I have given two practice problems. So in the next presentation, we will be discussing about decision tree, and this association rule mining is in chapter 6 in the data mining concepts and techniques textbook. You please go through the textbook also to know more detail about this a priori algorithm. Thank you.